Alright, so today we're going to be in 4.3, which is graphing two variable inequalities. So before we start, I want you guys to try this one. This is review from what we did last week. So you try 2x minus 4 is greater than 18, or 3x plus 5 is less than or equal to 14. I want you to pause the video and try this one. Alright, so this one should have been a little refresher. Remember, when we have ORs, we have two arrows on the graph. So we're going to have essentially two answers on the same number line. So the first thing I'm going to do is I'm going to solve this guy right here. So I'm going to add 4 to both sides. We have 2x is greater than 22, divide by 2, and x is greater than 11. There's one answer. Then I'm going to come over to the other one, the OR, and I'm going to solve this one. So I'm going to subtract 5 from each side. We have 3x is less than or equal to 9. Divide each side by 3, and x is less than or equal to 3. Now, once you get to that point, what are we doing? We're putting them on a number line. So come down to the bottom, make a lovely number line. Okay. Smaller number goes to the left, bigger number goes to the right. Okay, so if I'm looking at 3, we're looking at this guy in the orange right here. So I have x is less than or equal to 3. Less than or equal to would be a closed circle, because it's equal to, and x is less than, which means we're going smaller. Okay, now look at 11. Now I'm looking at the dude in green. X is greater than 11. Greater than means an open circle because it's not equal to, and x is greater than or bigger, so we're going to the right. So there's your graph. That was a review of compound inequalities. Now what we're going to do today is we're going to put these on our xy number line, or our xy axes. Okay, so we're going to go back to our graphing like y equals mx plus b. So a couple things to note. If we have a greater than or a less than sign, our line is going to be dotted. If we have a greater than or equal to, and then greater than or less than and equal to, okay, so less than or equal to, greater than or equal to, we are going to have a solid line. Okay, so you need to know this right here. Alright, so let's go ahead and try one. So the first one I want to try is y is greater than 3x minus 4. Okay, this is in y equals mx plus b form. So I can use my y-intercept, or my starting point, and my slope. So from that equation, what's your y-intercept? Your y-intercept would be the negative 4. And then what's your slope? Your slope is always the guy in front of x, so it would be 3. So I'm going to go ahead and put some dots on the graph, and then we will figure out whether it's dotted, solid, and then how to shade. So here's my graph. Okay, my y-intercept is at negative 1, 2, 3, 4, so I'm going to put a point. From that point, I'm going to count my slope, so I go up 1, 2, 3 over 1. Now I need to figure out if I'm dotted or solid. So look at your sign. Here's our sign, and it's greater than. There's no equal to, which means we are dotted. Okay, so I'm going to get my dotted, lovely dotted line here. And there's my line. Okay, put your arrows on the end. Now, how in the world do we shade? A lot of people will mess up if you just go strictly from the symbol, okay? So what I do is I pick a point that's not on the line. Any point that's not on the line. The easiest one is 0, 0. But sometimes the graph goes through that point. So you can pick any XY point that's not on the line, and we're going to come over here and write it. And we're going to test it out. We're going to see if it's true or false. If it comes out to be true, we shade over that point. If it comes out to be false, we shade away from that point. That'll make sense in a minute. So here's my x, here's my y. I'm going to plug that in. So I put 0 in for y, and then 3 times x is 0, and then a minus 4, and I'm going to simplify that. 3 times 0 is 0, 0 minus 4 would be negative 4. Okay, is this statement true or false? Is 0 bigger than negative 4? Yes. Since it's true, I shade over that point that I chose. If it had been false, I would shade the opposite side of our line. Okay, let's try another one. This one is y is less than or equal to negative 1/2 x plus 5. So the first thing I want you to do is tell me whether our line is going to be dotted or solid. All right, so this one again is in our y equals mx plus b form, so we can do our y-intercept or our starting point and our slope. The y-intercept is the number that's alone, so 5, our b value. Our slope is the dude in front of x, so negative 1/2. I'm going to go ahead and put those points on the graph. 1, 2, 3, 4, 5. I'm going to go down 1 over 2. All right, so dotted or solid, what'd you guys get? Remember, we look at our symbol. It is equal to, so we are solid. So I'm going to connect my points. Remember, your line has to go all the way through them. Do not stop at the points. Okay, goes through them with the arrows. Keeps going forever both directions. Now let's figure out where to shade. So to figure out where to shade, I'm going to circle a point that's not on that line. 0, 0 is our easiest one. The graph doesn't go through it, so we can use it. I'm going to bring 0, 0 down, and I'm going to plug it in. So y is 0, less than or equal to negative 1/2, times x is 0, plus 5. So 0 is less than or equal to negative 1/2 times 0 is 0. 0 plus 5 is 5. Is 0 less than 5? Yes. Okay, since that's true, we shade over the point that we circled. Okay, let's try another one. Next one is y is greater than negative 5/2 x plus 7. All right, so my y-intercept and my slope. My y-intercept is the b value, that's 7. My slope is the guy in front of x, which is negative 5/2. We can go ahead and put that on the graph. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1, 2, 3, 4, 5 over 1, 2. All right, solid or dotted? What do we got? We're looking at our symbol right here. There's no equal to sign, so we're going to do dotted. So connect, go through the points, okay? Remember, they don't stop at the points. There's my line. Now we have to figure out how to shade. So I'm going to take my 0, 0, since the line doesn't go through that, and I'm going to bring it over. And I want you guys to go ahead and pause the video and try that one on your own. All right, so you should have plugged in 0, 0. So 0 for y, and then 0 for x. And what happens? We get 0 is greater than 7. Is that true or false? That would be false. Since it's false, we shade on the opposite side of the line, so we shade above. Okay, let's try another one. Now this next one is going to be a little bit different because it's going to be in standard form. I want to make sure that you guys see one like that before we do practice on our own. So on number 4, we have 2x minus 3y is less than 12. So 2x minus 3y is less than 12. Now this is standard form. I prefer to solve for y if I get decimals. If I'm not getting decimals, I'm okay with cover-up method. So I'm going to make my xy chart over here. I'm going to plug 0 in for x and 0 in for y. And let's see what happens. When I plug 0 in for x, I get 2 times 0 minus 3y is less than 12. So 2 times 0, that's gone. So I'm going to divide by 3 on each side, negative 3, and y is negative 4. So there's my y-intercept. Now do the same thing for the x-intercept. So we're going to plug 0 in for x. So we have 2. No, I just did that backwards, didn't I? Sorry. That's my y-intercept. Now we're going to plug in 0 for y to find our x-intercept. So 2 times x minus 3 times 0 is less than 12. The 3 times 0 disappears. Divide each side by 2, and x is less than 6. That should look familiar solving for those. So there's our x and y intercepts. I'm going to go ahead and put those on the graph. And then the rest of the process is pretty much the same as what we have been doing. So my y, negative 1, 2, 3, 4. My x, 1, 2, 3, 4, 5, 6. Okay, I'm going to connect it with a dotted or solid line. Look at your symbol. There's our symbol. Okay, so what are we going to do? There's no equal to sign, so it would be dotted. Remember to go through your points. Your arrows on the end. Now let's figure out how to shade. So for shading, this line does not go through 0, 0, so I'm going to circle it. And then I'm going to plug in 0, 0 to my equation to figure out if I'm shading above or below. So I want you guys to go ahead and plug it in and tell me which way you're going to shade. Okay, so you should have plugged it in. 2 times 0 minus 3 times 0. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than 12? Yes. Okay, what's that mean? We're shading over that point. Okay, let's try one more. So this next one's going to be, again, just a little bit different. I want you to see it, though, before we end. So number 5 is y is greater than or equal to 4/3 x. All right, so this one's a little bit different. Y is solved for, so we can use our starting point and our slope. So I have my y-intercept, and I have my slope. My y-intercept, well, there's nothing over here. If there's nothing there, that's like adding on a 0. So my y-intercept is 0. My slope is still the number in front of x, so we have 4/3. So let's go ahead and put our points on the graph and see what our graph looks like. Okay, so my starting point's 0, and then I go up 1, 2, 3, 4 over 1, 2, 3. Okay, solid or dotted line. Remember, we look at the sign. It is greater than or equal to, so we're going to do a solid line. And then we need to figure out how to shade. Now the problem with this one is the line goes through 0, 0. So if I plug in 0, 0, it won't tell me how to shade. I have to pick some point that's not on the line. I prefer to pick points that are on the axes, because then I have either my x or my y as a 0. It's just easier for me to plug in. But you could literally choose any of these points. See all these orange points I'm putting on here? Any of these orange points are not on the line. You could choose any of them, okay? So let's choose one. Whoops. I'm gonna choose, let's do 0, 3. So this guy right here. So I'm gonna bring over the point that I chose, and I'm gonna plug it in. Here's my x, here's my y. So for y, I'm gonna put in a 3. For my x, I'm going to put in 0. So we have 3 is greater than or equal to, 4/3 times 0 is 0. Is 3 bigger than 0? Yes. Since it is, we shade towards the point that we chose. Okay, that is graphing two variable inequalities. Let your teacher know if you have any questions. You can go ahead and start on the practice.